Hello YouTubers, Peter here, Piotr Fisner from Right to the Repair, yes. Probably you can't read it, it's that dark here. But anyways, what I want to say is we've got a Microsoft power supply which was brought in as a donation when customer has bought in the like a third-party power supply which I'm ordering from China every so often. Not all the time, but every so often. And unfortunately, customer is not happy with the noise that that power supply is making. So I said, okay, no problem. I can look into your old one and try to fix it. As you know I fix as well power supplies. If you know. So yeah, here we got customer power supply, my power cord as well to test it out. I didn't plug it in yet. I don't know what's going on. So let's try to connect it and let's try to see if we will have an orange light. Okay, so do we have an orange light? We do. Okay. So if we've got the orange light, that means the standby voltage is there. Okay, so now what we should do is connect here so that we will turn this orange light into a white one and we will have 12 volts. So we can get this and we can try to do it. I will try to observe the there was an attempt. Okay, it's dying. Automatically when I'm doing it, it's dying. So it can have some short. It can have some short inside. Not anymore. Patient had died. That was his time. So now we need to wait some time before resurrection. But yeah, come on, yo. No, it won't work. I know you need some time, but we know we've got some sort of short. Okay, so we need to open it anyway. Can disconnect the mains. And we can start the surgery. Okay, I was trying to tidy up here. I can move again. I can again move, which is awesome. We need a screwdriver for it, and we need some flat screwdriver or even some picking tool to get. I don't have my usual picker, which would be really useful now. Because if you know how it's built, it's like a plastic tube around it, and the rubber is all over. So in order to dig it out, you need to put something on the side here, and then just pull it out. But with this, it will be difficult, and I don't have anything. I would have to have some either flat screwdriver, but a really small one. Which, to be true, I don't know if I can do with this one. Probably I don't, and probably I will. Yeah, I will damage the rubber. Okay, I will be gluing it in that case. Oh no, this one went out. Surprisingly, but it's not ideal. This is what it is. And then you get a screw, regular screw. If you have seen my other episodes about power supply. Yeah, I don't have the best way to do it. I know how it has to be done, you see here, yes, but I don't like the method I'm using, and I don't know of any better method. Let's put some light on. Maybe again with this one, which I don't believe will help, but worth a shot. Okay, it went out, you see, that's what I meant. Normally I'm having a bit different one, a flat one. Oh yeah. This plug is stiff. Oh! That was a jump, light year jump. And the last one, last but not least. Okay, can't fit it inside, maybe let's make different. Has to go in. If this picker won't go in, it won't work. Oh, went in. Cool. Happy days. Started, but it's not the way you want it. Okay, good. You see, I don't know if there is a perfect method to do it. Yes, the only problem is that it's this thing, it's plastic, and then this is a rubber, and whatever you're trying to do, it's never ideal. So now the part which you're doing, you can electrocute yourself. So if you don't know what you're doing, you should get trained, or you should get risk on your own. Yes, but never work on the plugged in to power mains if you're not sure, not 100% sure, because you can get killed. And always when you touch stuff, you should touch with this side of the hand. Yes, not this, because here are muscles which will crimp like that, and then you can't let go, and that's why it can kill you. So if you're working under the mains and you're not sure about something, don't touch it. But if you really got no other choice, which sometimes is the case, then wow, this doesn't have a shield. I haven't seen without a shield for such a long time, because usually they have a shield here. Look what a dirt. That caused the overheating, and then it's more here, yes, but that caused overheating. And oh, capacitors, look, we already see culprits. Okay, I've got capacitors, but the problem is that these capacitors I have are bigger ones, and I don't have this size of these capacitors. So either I will fit these, or we will have no fix. Because I've got here a 2200 microfarad and 16 volts. And here are 2200 and 16 volts. So they are. So yes. Okay, so the bottom. Oh, sorry. So it was the bottom shield. So I'm talking rubbish. So I need to desolder it right now. I mean, remove the shield on those two pins. Again, don't try to touch anything if you're not sure. Let's get soldering iron placed yesterday when I was finishing the Xbox. Well, fixing the Xbox One X. That should be previous day video. to me. I'll swap you with a bigger one, some chisel or something. As long as it's big, that's fine. The biggest one. Okay, that will do. Okay, plug this baby in. Let's hide this one and let's do it. Because after removing this shield, we already see that we've got an issue with, I don't know, a second. Okay, get it on the floor, not work with it here. I can zoom you in, I think. Okay, cool. $60 is doing magic, yes. Now the other side, I'm using the left hand, so this soldering iron costed me about, I don't know, 10 pounds. So, yay. I bought one person here, Dylan, to start learning as well. So he already started to learn these things. Hopefully he can fix for people one day as well. Well, not maybe power supplies, but other stuff, because that's high voltage. My recommendation for people who start work is to start off the low voltage devices, because then you've got up to only 20 volts, let's say, or 30 volts. And you don't have big voltage as it's here. So okay, so we see that this capacitor here is okay because it's flat. Yes, this one is flat, but these three usually are the culprits. So yes, we should get them out. Now, in order to not make a mistake, I'll zoom you in again. Okay. This side, this aluminium side, yes, I think it's aluminium. This side is a minus side. Oh no. Yeah, it is. It is, because this side is doing any action or screws, but not the element itself. So anyways, the minus side of these is here. Okay, so this line, gray line, it's on this side. So even if you would forget how to, how to do it, then you can't, because it's super easy how to mount them back. Yes? The only problem we have is that we might struggle with taking them out, because usually when I'm recording I've got problem. When I'm not recording, I'm doing okay. So yay, happy days. I could add some plugs actually, to be true, to make my life easier. Okay. We went on a holiday, so I didn't solder in the UK. So I found a way of putting blockage on the syringe, but now I should solder every day, or number of solders per day, so I shouldn't have a problem with drying things out. Oh, come on, you little tricky monkey. Let's get the first one out. Don't know if you can see it clearly. If not, sorry, my fault. Okay, the first one is out. We will check on the meter. I'll show you what was the capacitance. I think it's too close, and that's why you struggle to see. Okay, so this one is loose, and this one is loose. All of them has the same capacitance, from what I remember. My memory is really not great. I can do it because I'm stubborn and I spend too much time with them. Okay, we've got all of them. Oh, let's switch off the soldering iron. Now we've got holes okay, so it's fine. You can see yourself that the holes are visible, see-through, yes. Let's check these capacitors. You'll see the capacitance. Okay, so they should have a 2200. So 2000, that's next one, millifarads, yes. So let's check plus on a plus, minus, you see, it's 0, 0.3, slightly growing. It's a dead cap. That's why when it's starting up, it's black, no light. Same story here, yes. And third one, the same thing. So these caps are dead. Well, now let's get the new one. Look, 1.2.2.1, but it's a 10% I think tolerance on them, so it's 10.2.2 in 2100. How many percent? It's not showing the percentage of the tolerance, but usually they have like 10% tolerance. So we got 2.11, so 2000, oh, even 1200, so it's fine, yes. 2120. One, I don't know if I will be able to fit them. I ordered them, I didn't look at the size, it's my fault, but either this or no fix, so we've got no choice. Okay, it's within the tolerance. This is the smallest, 2.7, 2.8. Oh well, we can give it a bash. It's fine. So here's the power supply. Here are the three fellas. Here is a minus, so minus goes against that aluminum plate, and we have to make sure that we will somehow fit it. Yes, so let's put them in first, because that will be fun. Okay, you don't see what I'm doing. Second cut and the last cut. Oh, I didn't clean this hole well? Okay, well, I will struggle with you. Okay, what we can do is we can put these ones like this. Can try to solder these. How far it's going out? It would be better, yeah, it would be better if this would be angled, because then at least they touch with each other, but they are not going above the surface, and there are other components, so we can't allow them to go beyond. Now I'll get the power on. I think it's time to upgrade my soldering iron. I was thinking about buying a kit. What I'm doing, you wanna see probably? Cleaning up the tip. Now I can apply some flux, so the work will go smooth. With those regular components, most of the time I don't clean out the workplace here. Yes, I don't. To be true, if I'm doing SMD, I'm always cleaning up. Yes, I'm brushing. I'm doing everything there. But with these, I don't know why I just like. Oh, change battery. Well, change battery means change battery. So here's the battery. Should stop using these containers, because they don't have anything wet or anything, so that I could have a problem with it later. Okay. Come on. Okay, good. Use the charger to charge it up. Okay, let it charge and let's continue. So what I finished here, yeah. Can add a bit more. No harm in that. Okay. Now the culprit. Let's add a bit of a flux. Already see that one hole is smaller than the other one, so let's get this. Here, and let's try this time now. Okay, well, this one will be a problem for sure. So I need to do what I hate to do, but I'm left with no choice. Push it as much as I can. You know, it's either this or just struggle, mate. get in another power supply as well to fix like that. Okay, we can cut it and we can test it. Cut it off. Oop. That was the last one. I didn't want to touch it because I thought it might be more hot than it was actually. I was quite quick with it, so that's why it wasn't too bad after all. But anyways, you know, that's that job done. Let's hope that this will fit. Ooh. Okay. Now this part I would literally want to open, but I don't want to open it on the recording because it, you know, like no value for you to see. Now because of this capacitor I can't insert easily this thing, but we are missing this. We're missing this, which is a light on one side, and that's this side. Oh, we can try to put stuff back together. Who can tell me why I'm struggling? It's usually straightforward. My eyesight. That's the problem. My eyesight. Job done, guys. So yeah, let's turn off the light. Let's plug that baby in. Where is the power cord? And let's check this one out. Okay, we get an orange back. Yes, after the time down. So let's keep it this way so that we will see clearly in the center. Somewhere here. Let's try to do it this time. Okay. So there is some short other than capacitors. Yes, there is something wrong still. So guys, I don't know what it can cause that to be true. But it's not only the capacitors. So let's try to check the voltage. AC or on the cap, bridge rectifier DC, because it's behind the bridge rectifier. Nope, we don't have a power. Let's plug in the power. You got, okay, so we've got a power up till here, up till the capacitor. So the bridge rectifier stuff and filters and everything, that's working. Now this goes into the small transformer, so it gives us the standby voltage. That's why we see the orange thingy. Now, because we've got orange thingy, we know that the standby is working. Okay. Now the standby through the optical thingy here is making this transformer on, and then this transformer gives us the proper power to the Xbox. Yes, when we press power button. So now the issue is between here, let's say, and this transformer somewhere. Yes, but I will have to well, I didn't put the shield. That's a good thing for a test, because that would mean more work, but I need to see what else is wrong here. Okay, so now the problem only is that working under the mains is not nice. It's really not nice. Oh, don't like when things are fallen. And well, still power, so let's short it. Okay, get it off. Now, what can we see here? We know that this one is working, so this should receive a power. Here is separation in between this part and this part. So the question now is, when we put the power, how far this goes. Okay, how far the power goes. This, I don't need the big light, I need a small light. So, do we see from the visual inspection anything? No, nothing is burned. I don't see any burned stuff. Going on. Those are the optical thingies which pass on the information that the standby has a power on and then switch on. So this one sends the information, and then transformer, the main transformer, can turn on. But in this case, something else is failing here. So we know we've got 6 new caps and they are soldered well. I don't see any problem with soldering. Oh, my eyesight is not the best. Okay, there is one small bit. I've put too much solder on one side, but it's fine. So I can't say it's soldered badly. U801, so that's a chipset. 1500 microfarads. How's this? I know it's there is more capacitors. have this capacitor probably in stock. Only the problem is that I can't measure it here. I can only partially check it because it's in the circuit. That's 1500, so that's fine. If it's 1500, then I wouldn't say it's a problem with it. Yeah, 1300. So it's 1500 and 20%. It is off, but it shouldn't be a problem. Now this big cap, what's the capacitance on the big cap? I don't see where are those two pins. Here are those two pins, okay. What's your capacitance, big boy? Okay, I'll put to 20 millifarads. It should be discharged when I'm doing it, by the way. What? 0.15. So 150. It's showing only 162 microfarads. It should be thousands from what I remember. Yes, 161. Hey, big boy. 400 volts. I can't see the. It would be nice to get it out to see your capacitance, maybe. If you're not showing us, how we can be sure? You're slightly too big. I'm trying to cut off the excess of this. Okay, trying to lift you up and read. No, that's actually 180 microfarads. I'm talking rubbish, guys. So 180 microfarads and 160 showing, then I wouldn't say it's a problem. Okay, so those two capacitors which I've checked are fine. Again, an S. So let's leave the problem with capacitors for now. And let's look for other problem. Now, I don't know everything from top of my head about the build of this, so I can only follow the follow the schematics, yes, or use general knowledge I have, but my general knowledge about it is not that great, so I'd rather base on the schematics. Two more capacitors, but I'll pause and I'll look for the schematics for this one. Okay guys, because I can't find quickly schematics, and I don't know why. I know why, because I'm on the Windows and I'm not on the Linux, and on the Linux I've got everything. I will have to switch back to the Linux, or I will have to Google for the schematics now. But I'll make it as a part 1 now. I'll try to stick with it and just find the fault, and then I won't fix it probably, but I will try to recognize the fault, and when I will find the fault, I will try to put second part of the recording so that this recording will be done in front of you, yes? But for now, we've got part 1. I've replaced 3 capacitors which were dead. We've seen the capacitance was actually not as it should. I've checked the other capacitors. I will desolder them just in case, and I will check them off the main board of the power supply. If the capacitance will be okay, then I will be 100% sure that none of the capacitors other than these 3 should be replaced. If I need to replace, probably I don't have them in stock, so I need to order them. And I will check what's wrong, yes, as well, because it's looking like typical power failure because of the capacitors, but maybe there is something else. That's why I want to follow the schematics and see, because there is a chipset for the control, so you know, I want to just be on the safe side and I understand what I'm doing, not just guessing what I'm doing. So guys, thank you for the part 1 that you've watched that, and if you want to wait on a part 2, or maybe there is already when you're watching it, you're welcome to do it. But guys, if possible, let's fix them all, yes, as I'm trying to say all the time. See you in the next video. Bye bye.